Welcome to the Copperfield Electric Podcast. Imagine this for a second, right? It's 2 in the afternoon on just a blistering August day in Southern California.
Wow, the worst kind of heat.
Exactly. And out of nowhere, the ground starts to roll. It's a major earthquake. The power grid instantly goes dark. You're shaken up, obviously, but you kind of smile to yourself because you just dropped like $15,000 on a top-of-the-line natural gas standby generator.
Waiting for that hum.
Right. You wait for that familiar hum of backup power.
Yeah.
But 10 seconds go by. A minute goes by, nothing. You walk outside to check on it, and you realize that the exact safety device installed on your house to protect you from the earthquake has instantly and permanently disabled your brand new generator.
Yep. It's just sitting there.
Turning it into a very heavy, very expensive lawn ornament. And we are exploring a paradox today that is just absolutely crucial for anyone looking to protect their home from grid failures.
It's a huge issue.
It really is. But to unpack how to actually solve that paradox, we have to talk about the experts making today's deep dive possible, which is Copperfield Electric. They are essentially the backdrop for everything we're digging into today.
And they know this stuff inside and out.
They really do. I mean, Copperfield Electric is a family-owned 24-hour electrician service based right here in Orange County. So if you are sitting in, Irvine, Anaheim, Santa Ana, Costa Mesa, or Newport Beach, these are the folks you definitely want in your phone.
Absolutely.
They do all the complex electrical engineering so you don't have to. They provide 24/7 emergency services, which, let's be honest, is exactly what you need when the lights unexpectedly drop at 2 in the morning.
Right, because disasters don't really respect business hours.
Exactly. And every single technician is background checked, bonded, insured, and fully licensed. That license number is 109474 a year, so you know exactly who you're dealing with. And they back it all up with a 100% satisfaction guarantee. So, just let them take care of the heavy lifting.
It's just smart to have them on standby.
Definitely. Now, with that baseline established, let's look at today's core source material. We are examining this highly detailed July 2026 guide by an author named Shiva, asking a question that seems, simple on the surface. Are natural gas generators better for home backup?
It's a question everybody asks.
Okay, let's unpack this.
Yeah.
Because natural gas standby generators are incredibly popular, right? They're like the default choice for a lot of people.
Well, absolutely. They really are.
But this guide makes a super compelling case that natural gas might not automatically be the perfect, flawless silver bullet for every single house.
Yeah, it's definitely not a one-size-fits-all solution, and I think that's what makes Shiva's analysis so valuable here. When people start shopping for home backup power, they almost always fixate on the fuel type first.
Right.
And natural gas pretty much always sits at the top of the wish list.
Yeah.
But to really understand why it's so popular and, where the hidden traps are, we need to look at the mechanics of how these systems actually operate when a crisis hits.
So mechanically, what's happening?
Well, a natural gas standby unit doesn't rely on a giant steel storage tank sitting in your side yard, right? It's permanently plumbed directly into your home's existing utility gas line.
So it's essentially tapping straight into the city's underground infrastructure.
Exactly. That is the core of its appeal. And the magic of this system, the thing that makes it truly standby, relies on a piece of hardware called an automatic transfer switch, or an ATS.
An ATS, got it.
Yeah. When a utility outage hits, this switch acts like the central nervous system of your home's electrical panel. It physically monitors the voltage coming in from the grid, and the millisecond it detects a sustained voltage drop, it just kicks into action.
Like immediately.
Pretty much. First, it automatically fires up the generator's engine. Then, it mechanically isolates your house from the dead utility grid.
Oh, wait, I want to pause on that isolation step for a second. Because I always assumed the generator just, fed power into the house.
Yeah.
But it actually has to act like a physical gate to stop power from flowing backward.
Yes, exactly. Right.
Because if your generator pushes electricity back out into the neighborhood grid, you could seriously injure a utility line worker who thinks those wires are completely dead.
That is such a critical point. The transfer switch essentially drops a physical barrier between your home and the grid. Once that safety barrier is in place, it transfers your home's electrical circuits over to the generator's alternator.
Okay, so it's a very controlled handoff.
Right. And the whole process takes maybe, 10 to 15 seconds. And because the engine is drawing straight from the municipal gas supply, it can theoretically run indefinitely, as long as the utility company keeps that underground pipeline pressurized.
which is an incredibly attractive proposition. I mean, if I can use an analogy here, having a natural gas generator is basically like having your house hooked up to the municipal water supply. You just turn on the tap and the water flows.
You never even think about it.
Exactly. You don't have to think about the source. Whereas relying on a traditional fuel tank, like a propane tank, is more like relying on a giant water tower in your backyard. Yes, it holds a massive amount of water, but it's fundamentally a finite resource, right?
Right. Eventually it runs dry.
Yeah. One is theoretically endless, and the other requires you to constantly monitor a gauge and ration your usage so you don't run dry on, like, day 3 of an outage.
If we connect this to the bigger picture, you can start to see why this endless supply matters so much psychologically to a homeowner.
Oh, 100%. The stress relief.
Yeah. Think about the physical conditions that usually trigger a prolonged power outage. We aren't usually talking about a mild, breezy afternoon here. We're often talking about a multi-day, severe heat wave where the grid simply collapses under the weight of, like, a million air conditioners.
Just a miserable situation.
Completely. Transformers are blowing out. The inside of your house is creeping up to 90 degrees. Everyone in the neighborhood is miserable. In that highly stressful, highly uncomfortable scenario, having a hands-off fuel supply that you never have to actively manage, I mean, that offers unparalleled peace of mind.
And the guide points out that the peace of mind extends to your wallet, too, because the economics are just staggering. Based on the 20 Trump fixed utility rates in the guide, running a natural gas standby generator costs roughly, I think it was $20 to $50 per day of continuous operation.
That's right.
But if you take that exact same generator and run it on propane, you are looking at a steep $100 or more per day. I mean, over a 5-day outage, you're saving hundreds of dollars just on the fuel.
The daily operating cost is a massive advantage. But, the logistical benefits of natural gas extend beyond just the utility bill. Natural gas actually burns significantly cleaner than diesel or gasoline.
Oh, really?
I didn't know that. Yeah, which means less carbon buildup inside the engine and less maintenance over time. Plus, you don't have to pay annual tank rental fees to a supplier. And perhaps most importantly, during a widespread regional disaster, you don't have to schedule a delivery truck to come refill your tank.
Oh, man. Trying to get a delivery truck during a disaster. Good luck.
Exactly. If the roads are blocked by fallen trees, or if the local fuel suppliers are simply overwhelmed with thousands of desperate phone calls, your underground natural gas line is theoretically immune to all of that surface-level chaos.
Okay, but this is exactly where I started finding a massive logical flaw in this whole infinite fuel narrative.
Yeah.
This hands-off supply sounds absolutely perfect until you realize it has a fatal dependency.
Right. It's not magic.
It's completely reliant on the municipal infrastructure remaining perfectly intact. If the very infrastructure providing that fuel is compromised, your infinite supply drops to zero instantly. And that leads us to a very specific, very critical environmental risk, especially for our folks living in Southern California.
The California catch.
Yeah, the catch.
It's the elephant in the room for any homeowner on the West Coast, really. Earthquakes. In California, local building codes and safety standards are heavily dictated by seismic activity.
Makes sense.
Right, because an earthquake can rupture underground gas lines and cause catastrophic neighborhood fires. Many homes in these zones are equipped with seismic shutoff valves on their main gas lines.
I've seen these. They're usually these little devices bolted onto the gas meter on the side of the house. I'm assuming there's some sort of mechanical trigger inside that reacts to the physical shaking of the ground.
That is precisely how they work. Inside the valve, there's typically a small metal ball bearing resting on a very precise, shallow pedestal. When the ground shakes hard enough, usually at a magnitude of about 5.4 or higher, the physical vibration knocks that ball bearing off the pedestal.
Oh, wow.
Yeah, it just drops down into the gas pipe and completely plugs the line, instantly shutting off all gas flow into your home.
Here's where it gets really interesting, and honestly, this is the paradox I mentioned at the very beginning of the deep dive. You install the seismic valve on your house. The big one hits. The valve senses the shaking, the ball drops, and it automatically slams the gas line shut.
It does exactly what it's supposed to do.
It does its job perfectly. It prevents your house from filling with explosive gas. It's a brilliant piece of safety engineering. But by doing its job, it instantly severs the fuel supply to your backup generator.
Yep.
The exact safety feature designed to protect your home from an earthquake is the very thing that kills your backup power in the immediate aftermath. which is exactly when the utility grid is down
Yep.
and you need that power the most.
What's fascinating here is the sheer tension between physical home safety and power resilience. It's really an engineering paradox. You are actively protecting the structural integrity of your property, but you are sacrificing your independent power generation to do it.
Yeah, it's a huge trade-off.
It is. And because of this very specific vulnerability, the guide points out that homeowners in earthquake-prone areas have to completely rethink their strategy.
So if you live in Orange County and you know an earthquake is going to trigger that valve, what's the play? Do you just accept that you won't have power after a major seismic event?
Not at all. You just pivot your fuel strategy. Some homeowners opt for a hybrid approach. They'll pair a large natural gas generator with a smaller secondary portable propane generator just to keep the refrigerator and a few lights on.
Okay, that makes sense as a backup to the backup.
Right. But more frequently, homeowners in high-risk seismic zones abandon the idea of a natural gas standby unit entirely. They move entirely to a dedicated propane system.
Oh, really? Completely away from natural gas.
Yeah, because an on-site propane tank, assuming it's properly anchored and strapped down to code, remains completely usable after the ground stops shaking. It doesn't care if the municipal pipeline grid is shut down.
That makes total sense. You're trading the infinite nature of the underground pipe for the localized physical security of a heavy steel tank sitting on your own property. You know the fuel is there, regardless of what happens to the city's infrastructure.
Exactly. You control it.
And frankly, if a massive quake hits and the 405 or the 5 freeways are buckled or completely gridlocked, no propane delivery truck is getting into your neighborhood anyway. So having the fuel already sitting on your property is a huge advantage.
It changes the entire risk calculation. But seismic risk isn't the only time natural gas underperforms compared to propane.
Wait, really? There's more.
Oh, yeah. There is also a quiet, essentially invisible compromise happening right inside the generator's engine block. And it all comes down to the actual physics and chemistry of the fuel itself.
I want to stop on this power output issue for a second,
Yeah.
because the math in the guide completely upends how most people probably buy these units. I'm assuming this has to do with how much energy is actually packed into the gas.
It comes down to a concept called energy density. Natural gas simply has a lower energy density than propane.
Okay, lower density.
Right. If you look at them on a molecular level, natural gas is primarily methane, which is one carbon atom surrounded by 4 hydrogen atoms. Propane is a heavier, more complex molecule. It has 3 carbon atoms and 8 hydrogen atoms.
So it's literally a bigger molecule.
Exactly. When the spark plug fires inside the engine, breaking those carbon bonds is what releases the heat and mechanical force. Because propane has more bonds to break in the exact same volume of space, there is literally more combustible energy packed into every cubic foot.
So if I pump a cubic foot of natural gas into the engine, it simply cannot generate the same physical explosion as a cubic foot of propane.
Precisely. And that physical reality translates directly to the electrical output of the alternator. The standby generators you buy are usually designed to run on either fuel. But because natural gas is less energy dense, the engine just can't produce as much horsepower from it.
That is wild.
The guide provides a really stark benchmark for this. A generator that is rated on the box to produce 22 kilowatts of power when running on propane might only output 19 to 20 kilowatts when it's hooked up to your natural gas line.
Wow.
Yeah, you are losing roughly 10% of your total power capacity simply because of the molecular structure of the fuel.
Okay, let's take that a step further and apply the 80% rule that the guide just really hammers on.
Yeah.
Because I've seen this 80% rule mentioned in a lot of electrical contexts. I'm assuming it's like driving a car. You can't redline the RPMs on your dashboard for a 3-day road trip without blowing the engine, right?
That is a perfect analogy. The 80% rule is a fundamental principle of mechanical and electrical engineering. It states that a generator should not be continuously loaded past about 80% of its maximum rated capacity.
Got it. And by continuous, what do we mean?
By continuous, we mean heavy appliances that cycle on and run for long periods, like your central air conditioning compressor or a well pump, not just, a toaster you use for 3 minutes.
Right. Because if you run it at maximum capacity for days on end, the heat just builds up exponentially.
Yes. The thermal mass becomes too much to dissipate. The engine oil breaks down faster, the copper windings inside the alternator get incredibly hot, and the protective varnish on those windings can literally melt, causing a short circuit.
Oh, man. So it just destroys itself.
Yeah, you will drastically shorten the service life of the unit, or just cause a catastrophic failure mid-outage. It's the exact same thermodynamics that dictate the electrical code for the circuit breakers inside your house. They're designed to handle continuous loads at only 80% of their rating to prevent overheating and wall fires.
Okay, so let's run the actual math on this, because this is where a homeowner could really get themselves in trouble. Let's say I go to the store and buy a massive 22 kilowatt generator. I feel great about it.
Right, big investment.
But I hook it up to my natural gas line. As you just explained, because methane has a lower energy density, that 22 kilowatt rating immediately drops to, let's say, 19 kilowatts of actual output.
Right. That is your new baseline maximum.
Now, I have to apply the 80% rule to protect the engine from melting down during a 3-day summer outage. So if I take that 19 kilowatts and multiply it by 0.8, that leaves me with exactly 15.2 kilowatts of safe, continuous, usable power.
Yep.
I mean, I paid for a 22 kilowatt machine, but I can only safely rely on about 15 kilowatts. That is a massive discrepancy. If I didn't know that, and I tried to run my central air conditioner, my refrigerator, and a sump pump at the exact same time, what happens?
This raises an important question, and it is the crux of the entire guide. If you ignore the fuel density drop and the thermal limit, you are going to overload that alternator the first time a major heat wave hits.
So it just fails.
The engine will start to bog down, the electrical frequency will drop, which, by the way, can actually damage sensitive electronics in your house. And the unit's internal computer will likely shut the entire system down just to protect itself.
So you're left with nothing.
Exactly. You will be sitting in the dark next to a $20,000 machine that turned itself off.
Which completely defeats the purpose of buying it in the first place.
It does. And this is why sizing a generator is an engineering task, not just a guessing game in the hardware store aisle. It's why consulting with licensed professionals, like the team at Copperfield Electric, is non-negotiable.
Because they actually do the math.
Yes. They perform highly specific mathematical load calculations. They look at the starting amperage spikes of your specific AC compressor, the continuous draw of your medical equipment, and they factor in that 20% safety margin and the natural gas power drop before they ever recommend a specific unit size for your property.
So knowing that natural gas has these hidden limitations, both the seismic vulnerability of the underground pipeline and the chemical limitations regarding total power output, let's look at the physical realities of the alternatives.
Okay, yeah, let's do that.
If we're moving away from natural gas, we are basically looking at propane or a solar and battery setup.
Let's start with propane. We already know it costs more per day to run, and it solves the earthquake pipeline problem because the fuel is stored locally. But there is a hidden math to the physical tank size that catches people off guard. The guide notes that a standard 250-gallon propane tank does not actually give you 250 gallons of fuel to burn.
Wait, is that because of the 80% safety fill rule? I'm guessing this is also a thermodynamics issue?
Exactly right again. Propane is a gas at room temperature, but it's compressed into a liquid to be stored in the tank. When the ambient temperature outside rises, like on a 90-degree August day, that liquid propane expands significantly inside the steel tank.
Oh, so it needs room to grow.
Yes. To prevent the pressure from building up and physically rupturing the tank, safety regulations dictate that suppliers can only fill them to 80% capacity. This leaves an empty vapor space at the top for the liquid to safely expand into.
So your shiny new 250-gallon tank actually only holds about 200 gallons of usable fuel from the moment the delivery truck leaves.
That is your absolute maximum starting point. And for a standard 22-kilowatt generator running under a typical whole house outage load, those 200 gallons will generally yield about 2 to 4 days of continuous runtime.
Oh, wow. 2 to 4 days is not that long.
No, and if you are blasting the air conditioning day and night, you will burn through it on the faster end of that scale.
It really is like an hourglass. Propane is highly reliable, it's immune to the seismic valve problem, but it is strictly finite. You can literally watch the gauge on the tank tick down, and you know exactly when the power's going to die.
It's very predictable, for better or worse.
Which leads us to the other major alternative. If natural gas pipeline ties are vulnerable to earthquakes and propane tanks require constant refueling, we're basically looking for a fuel source that is disconnected from the earth and inherently renewable. That leaves us with the sun.
Solar and battery backup systems are fundamentally changing the risk profile of home power. From a pure hazard perspective, a battery system paired with solar panels has the lowest earthquake risk of any option.
That makes sense. Nothing underground.
Right. There are no high-pressure underground gas lines to rupture, no mechanical seismic valves to trip, and zero combustible liquid fuels stored next to your house.
And it essentially fixes the hourglass problem. If propane is an hourglass, solar is more like a rain barrel, but an active one. It's a rain barrel with a leak at the bottom, which represents the power your house is constantly draining, and a funnel at the top, which is the sun.
I love that.
The whole system works beautifully, provided the funnel is catching sunlight faster than the leak is draining the battery.
That is a great way to visualize it. It can theoretically run indefinitely without any dependency on a utility grid or a delivery truck if your solar array is physically large enough to fully recharge the battery bank while you're simultaneously running the air conditioner and the refrigerator.
Which is a big if.
It is a big if, but there is one final, incredibly practical hurdle we need to discuss when comparing all these systems, and that is the installation process itself.
Because putting in a natural gas generator isn't just plugging something into a wall. I mean, it's essentially performing major surgery on your property.
It is a massive construction project. A natural gas generator requires running new high-capacity underground gas lines from your main utility meter to wherever the generator is sitting in your yard.
Oh, man. The trenching.
Yes, the trenching. If your gas meter is on the front of the house and your electrical panel is on the back, that trenching, plumbing, and permitting work adds a staggering amount of cost and time to the installation.
And once that concrete pad is poured and those steel pipes are threaded, it is there forever. A natural gas standby unit is a permanent, hard-piped fixture. It's not something you can easily unbolt, toss in the back of a U-Haul, and take with you if you decide to sell the house.
No, not at all.
You are essentially marrying that specific generator to that specific property.
Whereas a propane installation, while still requiring professional installation and adherence to strict clearance codes, offers slightly more flexibility. The tank can sometimes be sited strategically to avoid long, destructive underground trenching across your landscaping. And a solar battery system, while permanent to the house, doesn't require laying any explosive gas lines at all.
So when we pull all of these risk profiles together, a very clear picture emerges. If you live in an area with a highly reliable underground gas grid, you aren't laying awake at night worrying about a 6.0 earthquake tripping your seismic valve, and your number one priority is having hands-off, infinite runtime during a severe heat wave of natural gas is an absolute champion.
Unbeatable in that scenario.
But if you live directly on a fault line in Southern California, and you are terrified of the municipal infrastructure collapsing and the freeways being blocked, you're probably going to lean heavily toward the localized security of propane tank or a robust solar and battery setup.
That is the exact takeaway of the guide. You aren't just picking a fuel, you are choosing which specific vulnerabilities you're willing to live with during a crisis.
So what does this all mean? It means that choosing a home backup generator is absolutely not a one-size-fits-all equation. You cannot just copy what your neighbor bought and assume it will work perfectly for your specific electrical needs and your local environmental risks. It's a highly bespoke, engineered choice based on your home's unique footprint.
It really requires a tailored approach.
It does. And listen, if you are sitting there right now feeling a little overwhelmed by the physics, if the 80% continuous load rule, the energy density calculations, or the seismic valve mechanics are making your head spin, you do not have to guess. This is exactly why specialized professionals exist.
Let the pros handle it.
Exactly. Copperfield Electric installs, services, and meticulously engineers standby generator systems for homes all across Tustin and Orange County. They understand the local seismic realities of Southern California, they know the building codes, and they do the complex mathematical load calculations so you don't have to. Let them design a system that actually turns on when the ground stops shaking.
That's the most important part.
Truly. You can call them to schedule a consultation at 626-622-9694 or reach them at 949-806-3807. Do not wait until the grid goes dark to figure out your backup plan.
And as we wrap up this analysis of fuel independence and infrastructure vulnerability, I want to leave you with a broader, perhaps more provocative thought to mull over.
Oh, I'm ready for this.
We are watching extreme weather events and natural disasters increasingly threaten our massive centralized utility grids, both the towering electrical transmission lines and the thousands of miles of pressurized underground gas pipelines.
Yeah, they're constantly under stress now.
Yeah, right.
As these interconnected legacy systems become more fragile and unpredictable, are we moving toward a future where the very definition of a smart home completely changes?
What do you mean by that?
Well, perhaps the ultimate goal of modern homeownership will no longer be about how seamlessly you are connected to the municipal grid, but rather how completely you can sever those ties. We might be watching the dawn of an era where every single suburban house must become its own closed-loop, entirely independent power plant just to guarantee the lights stay on.